Hello everyone, welcome to my channel. Sorry that I haven't been recording for quite a while. I really hope that you will forgive me. Today I have a very interesting topic to you. So I wanted to give you a quick introduction to Ethereum and Web3 development. So before we get started, please hit the like button and subscribe, and now we can actually start. I'm not going to explain you what is Ethereum, what is Ether, how to perform transactions. I'm just going to say that to use Ethereum, you need some sort of wallet. What is wallet? Wallet is some sort of application or a device like this one, which allows you to interact with Ethereum, right? So it allows you, for example, to check your balance, send transactions, verify transaction history, and so on. You can do many different operations on this. You can even use it to identify yourself, like as an authentication mechanism. So in this tutorial, we are going to use MetaMask wallet. MetaMask is perfect for this example because you can use it as a browser extension. So you don't even need to install anything. I mean, you need to install something, but and only a browser extension, right? So then you create an account and we have a new wallet. We are going to use it later. Just please have that in mind that if you want to use this wallet and to send some funds into this, please backup your private key and mnemonic so you don't lose it. Once it's lost, you lose access to your funds. So please do it before. And I wouldn't use the wallet you're going to use for this tutorial as your clean wallet, which you want to perform the true transactions. I would create a second wallet, which is just for testing stuff. Once you have your wallet, we can actually create a new next application. I'm going to skip through this part, just let you know about the most important parts, because I created a full-fledged tutorial how to create an application using Next.js. You can just find it here or here. There's a link, like 7 different episodes or 9 episodes, I don't even remember, but everything is explained there. So just follow it. So we type yarn create next app -- TypeScript. I love TypeScript, so we are going to use TypeScript. Just before we start, I need to mention that all the code in this tutorial will be written in TypeScript and JavaScript. So it's good if you are familiar with this, and the framework we're using is Next.js. So you're sort of supposed to know basic React, like hooks and context API and stuff like this. I also have videos regarding this on my channel, so just take a look there. Let's get started. We're going to install 2 packages. The first one is Ethers and UseDApp. So Ethers is the library which helps us to communicate with the blockchain, like listen to transactions, check balances, and so on. And UseDApp is a wrapper for Ethers to help us to use it in React. Now we are good to start coding our application, but what are we actually coding, right? So in this tutorial, we are going to build a tool for developers. So this is like Ethereum faucet. So it allows developers to claim the testnet Ethereum and it sends it to them. So they can use this Ether to test their application before they are going live to production. So we are just going to give them a fake ETH, not really fake, but Ethereum which works on testnet. So it's safe to play around with this. That's why I want to use the testnet, right? So the very first thing we need to do, we're supposed to define the DApp provider. And like probably you know React Context API. If you don't, there is a video which I explain how it works, and I'm building a very cool game, so it's very interesting to actually watch this video. But let's get to the point. So we create this provider, and to use Ethereum API, we need to find an actual API somewhere, right? So one of the free APIs we can actually use is infura.io. You can create an account there completely for free and just create an API key for Ethereum 1. Remember, use Ethereum 1, not Ethereum 2, because Ethereum 2 doesn't support transaction yet. It's just work in progress. So once you create your account, you need to just copy this API string, this API endpoint into our application and change the chain to Goalie network. Goldie network is a very common testnet for Ethereum, at least in 2022. Probably next year it will be deprecated, but the logic is very similar. Once we have it configured, we are actually good to code our application. So let's go back to code. Our application will be very, very simple. It will have literally only one button, which will do all the job for us. This button has literally 4 states. The state number 1 is when user has no MetaMask installed. We are just going to redirect him to MetaMask website, so they install it and create a wallet and so on. Otherwise, if you don't have this wallet, you will not be able to use this application. This is a hard rule. But you might ask, how can we actually detect if user has MetaMask installed or they don't? Actually, there is another package for this provided by MetaMask. It's called detect provider. And we can call this function and it will reveal if user actually uses a proper MetaMask installation. If they don't, it will return false and we will not be able to use this application. The second state is when user has MetaMask installed, but they didn't connect the wallet into our website. So they need to trigger the action, the connect wallet. So once you hit the connect wallet button, the MetaMask will display you a prompt asking if you want to allow our website to actually use our MetaMask account. If user agrees, we'll have access to their wallet balance and we'll be able to perform transaction in their favor. They always need to approve transactions. Just have that in mind. That will not control the wallet. We'll just only be able to send a request to this wallet, nothing else. We'll not be able to steal their funds. The third state is when user is already connected and they are in the wrong network. By default, MetaMask is using the mainnet, so it's actual production Ethereum network, but in our case, we want to use Goldie. So we will work on the testnet. So we need to request this wallet to change the network to Goldie. And obviously it will also display a prompt to the user that we are actually changing the network to Goldie and there's a testnet. So we are not using a true ETH. It's just testnet ETH, right? It's very important for user to know that it's not a proper transaction. And the final state is that the wallet is operational and user can claim Goldie ETH from us. So we can actually sign messages with this wallet and sign transactions with this. It's very important because otherwise we will not be able to actually interact with this. As you can see, this method is a bit more complex than the other ones because what actually is supposed to happen when user clicks claim Goldie ETH? Obviously, we want to send him some Ethereum, right? Testnet Ethereum, obviously not true Ethereum. So it means that our application needs to have their own wallet, which will contain a lot of Ethereum. And once user comes and requests some Ethereum, we'll send it to him. So obviously we need to create a dedicated wallet for it. Since we need a dedicated wallet, probably it makes sense to somehow guard it. So we might need to implement an API, which will be containing like securely stored our credentials to the wallet. Look, this wallet will have a lot of Goldie ETH in their wallet. So it means there's some fraudulent user who could come, just take all this Ethereum and just run away. And we want to avoid it, right? So we need to create an API. We also need to prevent users to claim Goldie ETH in infinite way and also dispatch it to users which actually didn't really request it. So we will need to limit users to actually consume this API, for example, once per day, and we'll require them to confirm their identity. So that user will need to confirm that they own this wallet. How can we do this? Actually, MetaMask and every other wallet have this feature of signing messages. So user can use their wallet to sign some sort of text. Like for example, we'll generate, "Hello friend, please confirm this message." And there will be like some sort of dedicated string, like for example, announce, which is in our case unique timestamp. And we are going to ask user to sign this message. It will generate the signature. And our backend will verify if this message was signed by this wallet. If it was, we'll send the tokens to it. We don't really want to send Ether to people who didn't request it, because they might don't want it. So that's very important to have some sort of security check. So let's get started with our backend. But before we start with our API, we're supposed to create an Ethereum wallet for this API. And this time we are not going to use MetaMask to do this, but we actually will use Ether's library. So how to create a wallet with Ethers? So you just call ethers.wallet.createRandom, and this will generate you a new wallet credential. Please remember to persist those credentials. We are going to need them in the future. Once our wallet is created, we need to create a new API endpoint, which will support only the post method, and it will accept 3 arguments: address, signed message, and signature. We are going to verify those triplets and confirm user's identity if this message was actually signed by the wallet which is claiming this Ethereum. If won't, we'll not send him any tokens. So how can we do it? We just need to install one additional library, which is called Ethereum Signature Utility. It's actually also provided by MetaMask. It's super simple. Now we need to import recover personal signature from this library, and we need to pass the message and the signature into it, and this function will return us the wallet address which actually signed this message. And now we need to compare this address to the address given by the API. If they match, we can send them tokens. If they won't, we need to revoke this request. Now our API is ready, so we can actually hook it into frontend. How can we do this? We need to use the app, and we are interested in one property returned by it, which is called library. A library contains JSON RPC provider, which allows us to communicate with blockchain. So this thing contains a signer. We just need to get it. And this signer allows us to sign messages with user's wallet. We can do it like this. Once we have it, the user will receive the request on the screen to actually sign requested by us, the message by us, and they just need to confirm it. Once they sign it, we just pass this data, this signature to the API along with the message and wallet address, and our backend will simply verify if this was true. And obviously it was, so we can progress further. And now we are good to send tokens to the user. So now we actually switch back to the API, and now we are going to create another JSON RPC provider on our API side, but this time for our other wallet. We just need to create JSON RPC provider and then define our Infura API and Goldie chain. And once we have it, we need to initialize wallet, which we call ethers.wallet, and we pass our private key. So we actually have this wallet interactive, right? And from this point on, we are able to submit transactions. So now let's initialize the transaction. We just need to define the to field, which is our user's wallet address, and we need to define the value. The values in Ethereum are very complex because to submit a transaction, we need to convert our transaction into the smallest unit, which is Wei. So imagine that we want to send 1 Ether to the user. We need to convert it into Wei, and Ethereum has 18 decimals. So what does it mean? That if you want to send 1 Ether, you need to convert into Wei, which means that you type 1 and 17 following zeros. And we need to actually convert it to big number using Ethers. It's very tricky, it's quite awkward, but that's how it is. So now our transaction is good to go, but there is one problem. Our wallet has no Goldie ETH, right? So from where we can take it? And that's very tricky. So Goldie is still a proof of work network, so we need to mine tokens. There's another workaround. We can find another faucet online or ask somebody to actually submit us some tokens. I linked one other faucet in the description. Also, you can use mine, but you'll get very tiny amount of it because I have very limited amount of it. But unfortunately, that's how it is. So that's how our application look like. There's literally one button which is actionable, and we just need to hit it to claim goalie it. You see that I need to actually sign a message. Once I sign it, I need to wait like several seconds. Usually it's under a minute, but it can be up to 3 minutes until I get it. And once I get it, then I have it, right? So that's all the code I wanted to show to you today. Hopefully you learned something. Please just go to my GitHub. You can actually fork this project, start it, just read the code, learn from it. You can feel free to contribute. If you have any questions, just drop them under the video. Hopefully this video was more interesting than the previous one. Hit the like and subscribe and stay tuned.